this unit, we're going to study similar figures. In this lesson, we're going to look at the notation we use to express similarity between figures. Alright, hi everybody. In this video, we're going to look at similar figures, but we're going to look at specifically the notation. And in the last couple of videos that deal with similar figures that I've done here, I have wanted to use this symbol. In fact, I kind of had to resist using it until we were specifically going to talk about it. So this little symbol here means the two figures are similar. Now, there's some missing detail here. How you would normally write this is triangle PQR is similar to triangle NOP. Okay? And so what's important here is that how you label and refer to the similar triangles is really important here because order matters. Because when you say that triangle PQR is similar to NOP, what you're saying here is that the angle at vertex P is the same as the angle at vertex N. The measure of the angle at Q is the same as the measure of the angle at O here. And the measure of the angle R is the same as the measure of angle P. Additionally, the side PQ corresponds to the side NO. The side QR corresponds to the side OP. And the side PR corresponds to the side NP. So the naming is really important because it communicates exactly what aspects of these two similar triangles correspond to each other. So with that in mind, let's take a look at some questions. Okay, let's have a look at some questions here. So if we know that the triangles below are similar, and we could use that symbol right there, what we want to do here is just take a look at what that means here. So the equal angles should be in the same position in both parts. Okay? So same starting angle, same direction as you move around the triangles. So if I'm going to state that this triangle right here is similar to this one right here, first of all, let's take a look here. What would be an example of an incorrect notation? Well, an incorrect notation might be if I said triangle, and let's just do it like this, ABC, and said that that was similar to triangle, I don't know, let's just start here, YZX. Okay. Now, although the two triangles themselves, in kind of a larger sense, they are similar, that is a miscommunication here because this says that angle A and angle Y are the same angle. But this one is a small acute angle. This is a much larger acute angle, like it's getting close to 90 degrees. These do not match up. So my labeling is incorrect here, right? Explain why it is incorrect. Angle A is not equal to angle Y. Okay, and by that token here, neither are B and Z the same, neither are C and X the same. So that would be incorrect here. So a better way to write this would be to say that triangle ABC is similar to triangle, and let's follow it here, X, Y, Z. And that does communicate what I want to do here. Now, the next question says, list all the pairs of angles with equal measure. Well, because of the way I've just labeled that, and I want to be able to see everything here, I've already done that. I know that angle A is equal to angle X. I know that angle B is equal to angle Y, and I know that angle C is equal to angle Z. Okay, so those are the pairs of equal angles here. And now finally, for this particular question, if angle A is equal to 25, and they should have degree symbols there. If angle A is equal to 25 degrees, angle Y is equal to 95, and angle Z is equal to 60, what are the other angles? Well, because of what I've got written here, this means that angle X is equal to 25 degrees, angle B is equal to 95 degrees, and angle C is equal to 60 degrees. Very, very easy to make that connection because I know that these triangles are similar. Okay, let's take a look at another one. Consider the diagram below, okay, where shape here LMNO is similar to FGHI. So we give you M is equal to 80, H is equal to 100, and and even though the symbol isn't written there, they should be there, degrees. Oh, and we are missing the side lengths there. Okay, so what we'll do here is I will make them up, just for convenience sake here. So let's say that LM equals 4 centimeters. Let's say that ON is equal to 3 centimeters. I've got two that are equal here. So let's not say that one here. Let's say that in this case that the intention was OL. OL was equal to NM is equal to 3 centimeters. And then that means ON was equal to 3.25. So what I'll do is I'll label it here. Oh. Actually, that's probably not what they intended there. Yeah, I'm going to have to... Okay, you know what? I'm going to make this one up here. I'm going to say, just for kicks here, I'm going to say that GF, because, yeah, I'm missing some information here. So I'm going to have to come up with a connection here. So I'm going to say that LM... Sorry about this, everybody. You know what? Until I started to do this, I didn't actually notice that those were gaps there. So we'll say that this is 3 centimeters. This is 3 centimeters. And then I'm going to say that GF here is this 3.25 centimeters. Okay, so M here is 80 degrees. And then H is 100 degrees. So what are the measures of angle N and angle G? Well, if I take a look at this right here, I know that M and G correspond to each other, so I know that G is going to have the same value as M. So angle G is going to be 80 degrees. And by that same logic, N and H are in the same relative position here in the names, so I know that those must have the same measure here. And because I know that H is 100, I know that N is going to equal to 100 degrees. Now, what is the length rounded to the nearest tenth? Okay, I'm going to say what is the length of, let's say, HI. Okay, HI. So this top right here. Oh, and I haven't given either one of those things. Oh, this is frustrating. Okay, so let's do it like this. Let's say that what they meant to say here was... Oh, shoot. Oh, yeah, I apologize. Wow, this would have been easier if I'd seen this beforehand, but that's okay. Got to make it up as I go, and we can do that. So what I'm going to do here is instead I'm going to say that OL and ON are equal to 3. So it's 4 centimeters, 3 centimeters, 3 centimeters. So now if this is 3.25 centimeters, now I can figure out what HI is. The reason I can do that is because if these are similar, then the two bases are in proportion to each other. So this is going to be my new, this is going to be my old. So it'll be 3.25 centimeters is the new, 4 centimeters is the old, and then that's going to be the length of HI over, and in this case, the side that corresponds to HI is going to be the ON here, which is 3. This is why I need to do a little bit more with this. So when I cross multiply, I get 3 times 3.25 equals 4 times HI, and then 3.325, 3 times 3.325. It's going to be 9.75 equals 4 times HI, and then we'll divide everything through by 4. And we get, rounded to the nearest tenth here, 2.4 is equal to HI. Oops, you can't see that. 2.4 centimeters is equal to HI roughly. Okay. That one was a little bit of a fight to get through here. Let's take a look at this one here. Label the following triangles such that they're similar here, okay? And notice that there are several possible answers here, and there are. So what I'm going to do to start off with is I'm just going to simply label this A, B, C, D, E, F. Okay? Basically, I just need to have names on the vertices. Now, after looking at this fairly closely here, I notice that A is the smallest angle in this first triangle, and D is the smallest angle in the second triangle. So if they're similar, if I can assume that they're similar, then those have got to be the same here. Then B is the obtuse angle, and there can only be one. And in this case, E is the obtuse angle, so those two must be the same, which leaves us C and F must be the same. Which means triangle, and I can choose to label this however I want. So for example, I could go BCA, and I know for some people the fact that I didn't do that in alphabetical order is going to be a little annoying, but it doesn't matter. But it's going to be the 2-line angle, 3-line angle, 1. So 2, 3, 1. So over here at this triangle, I got to do the same thing. 2, 3, 1, so that it'll be E, F, D. And as long as I have that same order, starting at the same angle, ending at the same angle here, when I label it, I can do this in a number of different ways. So for example, if I had decided to say that it was angle ABC, just to make things look kind of pretty here, then it's going to go, that was 1, 2, 3, so it'll be 1, 2, 3 here, so D, E, F. Anyway, I hope that makes sense.